Shielded arc welding is usually accomplished by means of an electric arc formed between the work and a coated metallic electrode. Let's see what happens. When the arc is struck, it almost instantly creates a temperature of about 6,500 degrees Fahrenheit. This melts both the base metal and the metal in the electrode. The metal from the electrode is melted off in tiny droplets, is carried across the arc and mixed with the molten base metal. The force of the arc and the forward travel of the electrode causes the mixed molten metal to be pushed to the rear of the crater, where it cools to form a beam. The movement of this metal toward the rear of the crater and the depth of the crater are an excellent check on the quality of the work. The operator should learn to use it as his guide. At the same time that the metal is melting, the coating on the electrode is being consumed. This takes place slower than the melting of the electrode, which shields the arc and helps direct the flow of metal. It also permits the use of higher currents, with the resultant faster deposit of weld metal. A gas is formed, covering the arc with a protective shield that prevents the exposure of the molten metal to the air and therefore prevents the formation of harmful oxides and nitrides in the deposit. Also from the coating, chemicals acting as cleansing agents enter into the metal to help to remove the impurities. These chemicals with the impurities float to the top and, cooling, form a coating or slag over the beam. This slag causes the molten metal to cool more slowly and has an annealing effect.
In all welding, suitable clothing must be worn to protect the welder. For oxyacetylene welding, goggles must be used with lenses of special colored optical glass which protect the eyes from the bright flame and the intense glare of the molten metal. The welding torch mixes the oxygen and acetylene together in correct proportions. Separate valves regulate the volume of oxygen and acetylene. In lighting the torch, the acetylene valve is first opened slightly, and a friction lighter which strikes a spark is used. The oxygen valve is then opened, and the mixture of oxygen and acetylene adjusted. Because the temperature of the flame can be varied to suit the type of work, the oxyacetylene welding process is a very valuable one.